Okay, in this lecture we're going to look at how the graphs of functions change when we have numbers in front of the function or numbers near the x values of the function. The first ones we'll look at are the type here, and we'll use the squaring function as an example. So this is like y equals f of x here, and it's the squaring function. And you can see here that this is the basic squaring function, which you should know. Then what we're going to look at is the blue one here. You'll see that this is really f of x, but we've got a 2 in front of it. We want to see what happens with that. And for the red one, this is like y is equal to a half f of x. We want to see what happens with that one. All right, now if we pick a few points, and we'll look at the squaring function itself, and we'll choose some x points, and then we'll look at what happens to 2x squared. So let's pick some values. -2, -1, 0, 1, 2. When we square it, of course, we get 4, 1, 0, 1, 4. Now what happens if we have 2x squared? Well, that would be 2 times each one of these. And you see that each of the new y values now are twice what the original squaring function y values were. And so you can see here that the function values are getting larger quicker than the actual squaring function does. And so you can see here, this is why this is narrower. Okay? Alright, so that's important to notice. Now, if you look at the one that has a half, here's x squared again, and now half x squared. And if we again use the same points, of course we have 4, 1, 0, 1, 4 again. Now what happens when we halve things? Well, of course this would be 2. This would be a half, 0 again, a half, and 2. And you can see that now it's wider. So whereas we had 2, 4, we have now got 2, 2, 2, which is right here. Okay. All right, so you can see here then that we can sort of summarize what actually happens to this particular graph. And if we have, for example, and we're looking at this in general, so let's have a look at what happens, say, the number in here in front we'll call a, for example, in general. And we're looking for when a is positive. Okay, we haven't looked at when a is negative yet, but let's suppose that a is positive. All right. Then what happens to y equals a of f of x in general? Now, when we had a 2, we need to look at now what happens if it's actually greater than 1. So if a is greater than 1, like in this case, then what we have is that y equals a of f of x, you can see here, is actually being vertically stretched because it's got narrower, so we've stretched it up vertically. Okay, involves a vertical stretch. All right, now in this case, if we look at if a now is between 0 and 1, so in other words we had this particular case here, we had a was a half, which is between 0 and 1, so it's still positive, remember. And so in this case here, y equals a of f of x involves a vertical shrinking. And you can see why, because basically this has all gone down this way, and so it's gone wider. And so you can see here 2 conditions. When a is greater than 1, involves a vertical stretch, okay, and if it's between 0 and 1, then we get a vertical shrinking. But the next one we want to look at is what happens if we now have the number in front of the x before we apply the function. So in this case here, our function I'm going to use is this half circle here, and you'll see that's the square root of 9 minus x squared. Now notice here that if we put an a in front of the x, like in this case here, a is a half, and in this case here, a was 2, what we're looking at is two situations. We're looking at this one where y is equal to f of ax. So we're applying a to x first and then applying the function. And we're looking at when y equals f of ax under two conditions. We're going to look at a, again, whenever it's positive, we're going to have when a is greater than 0 but less than 1. And we're going to look at what happens when a is greater than 1. There are two conditions where they change. Now if you look at this one here, we've got a as a half, so that's this particular condition right here. And when a is equal to 2, that's this particular condition right here. Now what happens when we do that? Well, here's our basic function, the black one. Now when a is equal to a half, right, then we're looking at this particular case here, and that's the red one. And you can see that what's actually happened is that we have actually got a horizontal stretch. So it's actually stretched the graph, all right, in the horizontal direction. Now in the case of when a is greater than 1, which is this case up here, this is the blue one, you can see that we have actually had a horizontal shrinking. Okay, so that therefore allows us to look at the conditions. All right, again, we have that a is greater than 0. All right, and then the y equals f of ax has the following things happen. Right, if I have that a is less than 1 but greater than 0, then we're going to have a y equals f of a of x involves a horizontal stretch. Okay, and if a is greater than 1, y equals f of a of x involves a horizontal shrinking. Okay, and appeal to these particular ones here. Now remember, the difference between these two is that here we're applying the function then the number a. In this one here, we're applying the number a and then applying the function. Okay, so make sure you're clear on that. Right, the next one we're going to look at is going to involve reflecting. All right, now in the case of reflecting, the first thing I'm going to look at is, let's look at this y equals the square root of x. So here's my function. And if I was to do a table of values, and we'll look at square root of x and a negative square root of x. And here's x. So we want to pick some values that are easy to do. Of course, x has got to be 0 or positive. So let's start with 0. Let's do 1. That's of course 1. When this is 4, this is 2. Okay, and so that produces this black graph. Now, what happens if we have a negative in front? Well, of course, it doesn't affect the 0. But now we get a negative 1 and a negative 2. So really what's happened is that this point has gone to this point, okay, and so forth. And this point has gone to this point. So in other words, it's a complete reflection, all right, in the x-axis. All right, and so when we have a negative in front of the function, okay, so if I was to generalize this, then what we would have is, all right, if I take y equals f of x, then y equals negative f of x, okay, it's going to be a reflection, so is a reflection in the x-axis. Right, now if we now look at this one over here, if I again do my table, x, square root x, and now square root of negative x. Right, we have to be a little bit careful here because we're going to find the square root of a positive number. All right, so we can't really draw these two together, other than the fact that if I actually did -4, I wouldn't get a value here, but I'd end up with a 2 here. Because the square root of -4, I can't do it, but the square root of -4 is the square root of +4, which is 2. And if I do -1, I don't get a value for this, but I certainly get a 1 here. If I get a 0, of course I get a 0 and a 0. So that's this point here. Right, if I use a 1, then I get a 1 here, but I don't get a value here. If I do a 4 here, I get a 2 here, but no value here. And so you can see what happens is that we actually get these points now, okay, and we actually get a reflection in the y-axis, okay. So when y equals f of x, then y equals f of negative x is a reflection in the y-axis. Okay, it's important to see when the function is working. So in this case here, the function is the square root of this x. Here we're applying a negative after applying the function. In this case, we're applying the negative before we apply the function. So always be aware which order is going in so that you can get the correct kind of transformation for the function.